This is a video looking at Euler Problem 1, 2020, and I'm going to start off with A, and I'm going to give an example of a simpler question. A set of 5 consecutive integers has the property that the sum of the smallest 3 have the same sum as the largest 2. So we need to write the consecutive terms using algebra. So let's do that then. n plus 1 plus n plus 2 are equal to n plus 3 plus n plus 4. So we've got 1, 2, 3, 4, 5. So let's collect the n's together then. We've got 3n plus 3, and we've got 2n plus 7. And if we solve that, we get n is equal to 4. So the largest term, is going to be n plus 4. So 4 plus 4 is going to be equal to 8. So the largest term is going to be 8. And we can show that this works by plugging in the value for n. So we've got 4, 5, 6, 7, 8. So the smallest 3 should equal the largest 2, or 15 does equal 15. Okay, so there's another method we can use. Now let's look at the positions. We've got position 1, 2, 3, 4, and 5. Now instead of choosing the first one as n, we can choose the middle. So here we have n minus 1, n minus 2, n plus 1, then n plus 2. So we are told that the smallest 3 equal the largest 2. So let's add the n's together then. So we've got 3n minus 3, 2n plus 3. So that gives us n is equal to 6. So the largest integer here is going to be n plus 2. 6 plus 2 is going to be 8. Jumped ahead there. 6 plus 2 is 8. And if you plug in n equals 2, you will see that this works. Okay, so the second one is a little bit more complicated. Now I'm going to give a partial solution, and if you can explain my solution, you will get credit. But obviously, if you can do the full solution with an explanation, you will get full marks. Okay, so this time, instead of dealing with a fixed number, we're dealing in the general case of m. In fact, we have 2m plus 1 terms. Okay, I think it's worth reading the question. So the question says a set of 2m plus 1 integers has the property that the smallest m plus 1 have the same sum as the largest m. So we've just partitioned the 2m plus 1 into m plus 1 and m, and if we add those together, we get 2m plus 1. Okay, so let's look at the general case. So let's use method 1, but you can use method 2 and get the same result. So we have n plus 1 plus n plus 2. Dealing in the general case, n plus m is equal to n plus m plus 1 plus n plus m plus 2 plus n plus 2m. Okay, so we've got the 2m here because we've got 2m plus 1 terms. Okay, so let's consider the left-hand side and the right-hand side. And let's collect together the ends first. So if we collect together the ends, I think it's reasonable to assume that we have m plus 1 ends. And let's be collecting ends, let's not put n as the coefficient. Then we have this lovely sum, 1 plus 2 plus 3 plus Okay, and you can write that as m plus 1 all over 2. And that just means the sum of numbers up to m is called a Gauss sum. Okay, so we've got that on the left-hand side. On the right-hand side, collecting ends, we have m ends plus m plus 1 plus m plus 2 plus m plus m. Okay, so for the right-hand side, let's collect together the m's. So we have m plus n on the left-hand side plus 1 plus 2 plus 3 plus m. And if we collect together the m's, we are going to have mn's plus m times m's. So if m is 10, we can count 10 m's. And then we have the sum 1 plus 2 plus 3 all the way to m. Okay, so let's scroll down the screen, and I hope everybody can recognize that this is the largest term. Okay, now this is only a partial solution. In your submitted answers, I would like explanations for each line and then a final answer. I'm not going to do a final answer for you. Okay, so we need the largest term, an equation for the largest term. So we need something using n plus 2m. So let's get rid of some of these then. We can expand out to get mn plus n plus 1 plus 2 plus 3 plus plus m is equal to mn plus m squared plus 1 plus 2 plus 3 plus m. So let's tidy this up by subtracting mn from both sides and subtracting this Gauss sum. Minus mn, subtract the Gauss sum. Okay, so if we subtract that, that goes, that goes, that goes, that goes. So we're left with m is equal to that goes, no it doesn't, that goes, that goes, that goes, that goes. Talking rubbish there. So we still have an m squared. So we got n is equal to m squared. Okay, now that's as far as I'm going to go. I would like you to write an expression for the largest term factorized. And if you can do that with a full explanation, you will get full marks. I hope this helped.